everyone, my name is P. Samyukta. I'm studying second year in Keshav College of Engineering. Today we are exploring an innovative application of AI in mental health diagnosis. Our focus is on using machine learning and natural language processing to detect schizophrenia from speech patterns, especially analyzing transcripts of what patients say. The main objective of this project is to develop a machine learning model that can detect schizophrenia from speech transcripts, to enable early screening and intervention, and to support doctors with objective and faster diagnosis. Our approach involves analyzing speech transcripts instead of audio directly. We focus on extracting features like word usage, sentence structures, studying syntactic patterns, semantic meaning. Then literature survey. Research in this area has evolved over time. Early research, which is in 1980s to 1990s, manual analysis of speech identified issues like poor coherence, disorganized thoughts, and in computational era, NLP techniques introduced features like word frequency and sentence of complexity were analyzed. Machine learning era, models like SVM and random forest achieved almost 70 to 85% of accuracy. Deep learning era, advanced models like transformers understand context and meaning better, more accurate, and automated detection. And in understanding the base paper uses a multiple stages pipeline. First, it extracts basic features like word count and sentence length, then applies deep learning model to understand context. Key findings are speech patterns can be used to detect schizophrenia. Important features include semantic coherence, vocabulary diversity, pragmatic language usage. Model achieved around 82% of accuracy, which is close to human level diagnosis. Next, research paper analysis. In research paper analysis, the data set and methodology, speech transcripts from if we have speech transcripts from 100 patients, they may have 50% of schizophrenia and 50% are controlled, were analyzed. Features include syntactic complexity, semantic coherence, and pragmatic markers. And then performance matrices models achieved almost 82% of accuracy with 79% of sensitivity and 85% of specificity. Feature importance analyzing revealed semantic coherence and syntactic abnormalities has most discriminative performance. Performance exceeded chance baseline by 32%, and in clinical validation, results correlated with clinical symptom severity scores. Each marker showed moderate correlation with positive and negative symptom scale ratings. And then proposed solution, our system improves upon the base model with transcript processing, converts speech into text, splits into meaningful sentence, and in feature extraction, extract syntactic and semantic features. And third point is model prediction, which uses multiple models to improve accuracy. And then enhanced features, added pragmatic analysis and discourse markers, used transformer models for better context understanding, applied SHAP values to explain predictions important for doctors. And then system architecture. System works in five stages. Data injection, which takes the input, which is audio or text. Pre-processing cleans and structures the data text. Feature engineering extracts important speech features. Machine learning core applies models to predict. Output generation use diagnosis codes and highlights key features. Next. Next, we are going into schizophrenia speech transcript uh, detection. Three-tier architecture. This diagram represents a three-tier architecture for schizophrenia detection from speech transcripts. The first block is presentation tier, which is a front end. This is the user interface built using React, HTML, and CSS. Here, the user can upload or enter a speech transcript, view prediction results, and see visualization. The result, like probability 0 to 87%, is displayed to the user. Application type, and in application type, which is a backend, this is the core processing part. Text processing, the input text is cleaned by converting to lowercase, removing punctuation and stop words. Tokenization and lemmatization. And in feature extraction, important features are extracted using TF IDF, bag of words, word embeddings, machine learning models, models like logistic regression, SVM, random forest, LSTM, BERT are used to classify whether the speech indicates schizophrenia, and an API layer handles requests like predict, upload, and sends result to frontend. And the last layer is data tier, which is a storage area. This stores transcript datasets, processor features, trained models, PKL files, evaluation matrices, flow, user inputs text. Processor, which is the first one is user input text, and then it goes to processor, and then it goes to feature extraction, then model predicts, and it shows the result with probability. Next, technology stack. We used Python for implementation, TensorFlow and Keras for deep learning, NLTK for NLP tasks, BERT models for understanding context, Fast API and React for interface, AWS for deployment. And after that, the conclusion and future directions are our system successfully demonstrates that AI can detect schizophrenia using speech patterns that achieves over 80% of accuracy. It can assist doctors by providing objective and fast screening. The future directions of future scopes are users larger and diverse data sets include audio and facial expressions applying in real world clinical environments. And thank you.